Hello, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my video. In this video, you will learn about Hess's law. This is a part of chemical energetics, and today we will learn on how to calculate the enthalpy change with Hess's law method. This is the learning objectives. Apply Hess's law to construct simple energy cycles. So without further ado, let's start our class by reciting Basmalah together. Bismillahirrahmanirrahim. Hess's law and thermodynamics. In 1840, the Russian chemist Germain Hess formulated a law which went to be known as Hess's law. Hess's law states that the overall enthalpy change for a reaction is independent of the route the reaction takes. This went on to form the basis of one of the laws of thermodynamics. The first law of thermodynamics relates to the conservation of energy. It is sometimes expressed in the following form. Energy cannot be created or destroyed, it can only change form. This means that in the closed system, the total amount of energy present is always constant. Hess's law and chemical reaction. Hess's law can be used to calculate the standard enthalpy change of a reaction from non-standard enthalpy change. For example, the enthalpy change for A forming B directly, the delta H1, is the same as the enthalpy change for the indirect route, delta H2 plus delta H3. So look at the reaction. So as long as the reactant are the same, look at the reactant here is A, both of it. So as long as the reactant are the same, and also the product, the final product are the same, they will have the same enthalpy change. So that the delta H1 will equals to the delta H2 plus delta H3. So that's the Hess's law. To make it clear, let's just jump to the question. Use the information below to calculate the enthalpy change for this reaction. CaCO3 produce CaO plus CO2. We have two reactions. The first is CaCO3 plus 2HCl produce CaCl2 plus H2O plus CO2, the delta H1. And then the second reaction, CaO plus 2HCl produce CaCl2 plus H2Cl. That's the delta H2. Okay, let's focus on the question. Don't look at the answer first. How to solve this question using Hess's law? Let's just do it slowly, step by step. So the first step that you need to do is make sure the position of that substance. Is it at reactant or at product? Let's do the first step, each substance. So we have to do the step each substance. First, let's focus on CaCO3, okay? So look at the CaCO3 for both of reactant. Which reaction that have CaCO3? Here, right, we have CaCO3 in the first reaction. Only in the first reaction. So after you found it, check the position. Where is the CaCO3? Oh, it is at reactant. So the position already the same. If the position's different, you have to make it the same by switch the reaction. So the reaction should be switched from reactant move into product and product move into reactant. But for this one, we don't need to do that step. Let's see how that step works for another substance. So for CaCO3, the position already the same. That's the first step. The second step is make sure the number also the same by looking at the coefficient. Is there any coefficient for the CaCO2 in the reaction? The coefficient is 1 because there's no number, so it means the coefficient is 1. You have to follow the reaction on the question. This is the reaction that we want to find the delta H. So we need to follow this reaction. Look at our CaCO3 in the first reaction. Look at the coefficient. Make the coefficient the same with our question here. Okay, so luckily it's still the same, so we don't have to do anything for the first reaction. So you only have to copy the first reaction. Write down again the first reaction here. The same. You don't have to change anything for the first reaction. Copy all the things for the first reaction. So we're done with the CaCO3. Now let's move on CaO. Do the same thing. Find CaO in both of reaction and then look at the position. CaO can be found in the second reaction and only in the second reaction. So we focus on the second reaction now. Look at the position. Is the position the same with the question here? CaO here is after the arrow, so it's product. But in the second reaction, it is before the arrow. So it is in reactant. We have to follow the question. So we have to make the CaO become product by switch the reaction. So we have to move all the reactant. It should be all of it. So HCl also need to move to the product. So all reactant move into the product and product move into the reactant. So we can see here, the second reaction already changed. So CaCl2 plus H2O produce CaO plus 2HCl. That's the first step actually. And the second step, we have to make sure the coefficient is the same. But luckily, the coefficient is the same now. But if not, if the coefficient is not the same, you have to make it the same by you can multiply the reaction or you can divide the reaction. Okay, the important thing here is if you switch the reaction, it will change the symbol of the delta H. If it's minus or negative, initially it will be positive after we switch the reaction. So the symbol of the delta H will change if you switch the reaction. That's important notes. And then if you multiply the reaction, if you multiply by 2, by 3, or depend on the coefficient, so if you multiply the reaction, the delta H will be multiplied also. Or if you divide the reaction, the delta H value, it will be divided also. So all action that you give to the reaction will affect the delta H value. Okay, so after you give action to that reaction, after that uh, we can check both of the reaction. Is there any same substance before and after the reaction. If we have the same substance, we can simplify it. For example, here we have HCl in the reactant. It should be in different part. If it is in a different part, we have HCl in the product, so we can simplify it. So we can let's just cancel it out. So no more HCl here because we have the same substance before and after the reaction. And then what else? We also have H2O, the same. Before and after we have one, so no more H2O. So I cancel it. And then CaCl2, also the same. So after I cross the same substance, so we only have this as our reactant, CaCO3. And then our product is CaO plus CO2. Okay, that's it. Only that's the reaction. After you total the reaction, yeah, reaction 1 and reaction 2, check again. Is our reaction the same with the question? Is it already the same or not? So yes, it's already the same. If it's not, there's something wrong with your step before. So you should have the same reactant with the question and the same product with the question so that we can use the Hess's law. So once it's already the same, the next step will be easier. So you only have to uh, count the total of the delta H. So the delta H is the delta H1 plus delta H2. So here, don't forget, we already switched the reaction, so it changed the symbol from negative, it become positive. So it is negative 17 plus 195. So the final delta H or the delta H for this reaction is 178 kilojoule per mole. That's it. Done. That's how to use the Hess's law. Okay, so it's time to practice. So please answer this question. Follow the Hess's law to solve this question. Okay, I think enough for today. If you're still confused, do not hesitate to ask me. So let's close our class by reciting Hamdalah together. Alhamdulillahirabbil alamin. Okay, thank you everyone for watching. Bye bye. See you on my next video. Assalamualaikum warahmatullahi